So the existing treatment plant was installed in 2005, and at the time it was considered a state-of-the-art technology, but through the 20 years since that technology was installed, we've learned a lot about membranes, when they're good, when they're not good, and how to better increase their life and apply them going forward in the future. So looking at the current plant, some of the issues that we have is it's not really effective at treating high turbidity water. We don't have an effective pre-treatment program or pre-treatment technology. Without that pre-treatment technology, we're sending water to the filters that excessively wears the filters and tires them out faster. We don't remove iron and manganese, and many people have complained about the taste and odor in the water, or they see orange or purple stains in their sink and their toilets, or maybe on their clothes. And currently there's also a lack of resiliency. So when we look at the current demands of the water plant, if we look at this black bar, the town in the summer uses a little over half an MGD for its residents, but the water plant filters only have a capacity of about 0.45 MGD. So on a peak day, the water plant can't even provide all the water for its residents. And in the event that one of those filters goes out of service, the capacity of the water plant is only about 22.22 MGD, and the average water use by the residents of the town of Silt is a little over 300,000 gallons a day, 0.3 MGD. So if one of the filters goes out of service, the town is actually going to struggle to provide water to its residents. So one of the things we're looking forward in the future is trying to come up with a treatment technology that addresses these issues, that is better at treating all the turbidity levels that we see coming off the Colorado River, will remove iron and manganese, and has an improved resiliency. So one of the things that we're looking at is the various water sources. So the town of Silt has a couple of alluvial wells that pull water through riverbank filtration, and then we send them to the water plant. The issue that we have with that water itself is it's really high in iron and manganese. The iron and manganese then contributes to the colored water that you see in your toilet or on your sink. It also has taste and odor issues. And the other water source that we have, though, is the Colorado River. The town's got great water resources on the Colorado River and should have those water resources going forward. It has sufficient water resources to provide the town to the water to the town and its residents. But one of the problems with the Colorado River is seasonally or during high runoff sessions, we get big spikes of turbidity, and that can overload the existing facility and cause treatment issues that then rely on excessive wear that could likely lead to failure. Okay, so when we're looking at going forward in the future, some of the things that we're trying to provide, we want to have a pre-treatment system that can accommodate the range and raw water turbidities that we see off the Colorado River. We want to remove iron and manganese. We also want to improve the resiliency. So in the event that one of the trains goes out of service, the town can still adequately provide water to its residents without having to truck in water, because that would be really expensive. So looking at those things, what we're trying to do is provide 2 pre-treatment systems that will reduce the turbidity and are effective at handling the range and turbidity we see coming off the Colorado River, which varies from, say, 150 to maybe 2,000 NTUs. And we're recommending a treatment process that is capable of doing that. Going forward to filtration, the current plant uses membrane filters. Membranes are a great technology, but you're going to have to replace them every 5 to 10 years. We're proposing going to a mixed media filtration. It's been a long-term technology, been around for centuries. We replace that media every 10 to 15 years, and the cost to replace those filtration media is significantly less than it is to cost to replace a membrane filter. We're talking about resiliency. So these bars represent projected water demands within the town of Silt. So one of the things we're trying to do is we're proposing 2 1 MGD trains. So if one train is out of service and we can only provide 1 MGD, we can still provide in excess of 1 average day water use in the town of Silt, even when we're looking at the 20-year projected flows. So that way we're addressing iron and manganese, we're addressing turbidity, and we're addressing resiliency. I want to go back and chat a little bit about iron and manganese. One of the things we can do in these mixed media filters is we could put in media that will remove iron and manganese, and that makes it a little more convenient. If we go to a membrane system, we probably want to do it in its own separate process and occupy floor space. Floor space equals higher cost. When we're looking at pre-treatment now, so we're going over to this graphic over here. There's a conventional flock sedimentation technology, and that's shown in the gray area or the white, faded back. That's a conventional process, lots of floor space. Yes, it can work, it'll achieve all the goals, but more floor space equals higher cost. We're proposing maybe looking at an alternative technology that uses a smaller, more compact footprint and uses a ballast to shrink that footprint. If we can shrink the footprint, we can shrink the building costs. If we shrink the building costs, we can keep the project cost to be something more economical. These benefits that this improved train will do is we're going to have improved resiliency, so we can produce water for the town of Silt. Even if one train out of service, we can meet the average day demands. We're going to remove iron and manganese. We're going to remove TOC and improve disinfection byproduct compliance. And we're going to accommodate the wide range and turbidity that we see coming off the Colorado River, addressing all the shortcomings of the existing facility.
Excellent.
So one of the things we're looking at when we're building this new facility is we're looking at this innovative procurement method called construction manager at risk. With that, we bring the construction manager, the contractor, into the design team early in the project. We help them evaluate the most efficient ways we can build these things. Some ways they can be like, you know what, if you change the dimensions of the building this way, we can use this form system. If I can use this form system, I can save X amount of dollars. Or maybe look at building type. Can we go with a steel building versus masonry? The contractors have real-time values on those costs, and they can implement them and bring them into the project team so we can make this cost-effective and value engineer the project to make it more economical. In order to minimize costs and ease transition and make it constructible, we're looking at constructing these improvements immediately west of the existing water plant on the same project site. So there'll be no real impacts to the average resident, but you will see construction happening adjacent to the existing water plant, where we'll be able to keep the current one in operation until we turn the new one on. So we did look at some other options. We looked at consolidating with other communities, but by the time we put in the infrastructure necessary to bring that water into Silt and pay the associated tap fees, that cost was on par with the cost we're looking at constructing the improvements at the existing water plant. We did look at several pretreatment technologies and several different filtration technologies, but overall the project team it believes this to be the best cost, best value for the town of Silt in meeting the desired treatment goals. So the average resident, when this new facility is constructed, what the first things they should notice is the water should taste better, because we're going to do a better job removing iron and manganese. It'll be more reliable. Right now you don't see an impact, but in the event that, say, one of the existing trains does go out of service, the town would immediately have to notify all the residents to conserve water, because they would struggle to provide enough water to the residents. With the new plant online, we're going to improve the resilience, so that won't be an issue going forward, and the town should be able to reliably supply water to all the residents, even in the event of a failure of one of their treatment trains. So right now, the design process has already started. We're trying to do preliminary site work to ensure things can move forward and the design can occur rapidly. And that design work and effort will continue all the way through the remainder of 2023. But in the beginning part of 2023, in March, we're going to submit a loan application to the state to see the amount of money available, see if we can get what level of principal forgiveness we can get, because the principal forgiveness is going to have a direct impact on what the rates are going to be to the residents. We're also actively seeking, I talked a little bit about this innovative procurement method. We're going to bring that contractor on board to help us get costs sufficiently, so by this March deadline, we can have a firm idea what the costs are, so we can establish the rates going forward. So with that, design will be completed at the end of 2023. We're probably looking at breaking ground and construction in 2024, with construction complete sometime in 2025. So with this technology, the lifespan of the treatment technologies will be approximately 20 years, properly maintained, oiling the bearings, keeping tear of the pumps, etc. Replacing, now there are some wear items. We're going to have to replace the filter media every 10 to 15 years. The building itself have a lifespan of 50 years, and we're going to, the main goal when we're designing this facility, though, is to make it easily expandable. We're trying to design it for 2 MGD of capacity now, but in the event growth exceeds our projections, we're trying to make it easily expandable where we can accommodate 3 MGD in the future. Funding options. Now, this is a major investment for the town of Silt, and we all realize that, and we're all actively seeking all the funding options that are available to the town. In the current regulatory environment with the bipartisan infrastructure law, there's a lot of money available to communities to invest in their infrastructure. With that, we've had some preliminary discussions with the state of Colorado and some of their funding agencies, and it looks like there's a significant amount of principal forgiveness that will be available to the town. We are actively seeking to increase as much or obtain as much of that principal forgiveness money as we can to keep the impact on rates relatively small. Alternative to that, we've looked at several different loan options to pay the remainder. We've looked at the state revolving fund. That comes with the least amount of strings attached to it, so it's easy to manage from the town's perspective. We've looked at the USDA funding, which has an option. They have money. Rates are about equivalent to what they are to about the state revolving fund money. However, it comes with a lot more significant overhead effort in managing that money, and that will take more investment from the town to manage and make sure we meet all the obligations that come with that funding source. While there are several other grants available, most of those grants are in the $20,000 to maybe $50,000 range, and pulling all those grants together and then managing and meeting their obligations for what's required to achieve those grants will be a significant effort that may not be able to, the town may not receive actually any benefit because they spend so much time trying to administer all the grant funding. So one of the things that we've looked at and feel is the best option for the town is obtaining money through the state revolving fund. In that, the state, the Water Resource and Power Authority, they basically pay a premium and pay down our interest rate on the common bond market. So if the common bond market is 4, we might get a bond rating of 3%, saving money. And that pairs well with actually principal forgiveness from the state through the bipartisan infrastructure law. So those two team well together, and that's primarily the funding we're seeking to move forward with this facility and the improvements.
All right, so with the design process, we're looking at a plant that costs roughly $28 million, and that's broken into really 2 different categories. About 2/3 of the cost is for basically replacing the plant in kind. 1/3 of the cost would allow the community to continue to grow. The population estimates would basically call for the community doubling in size over the next 20 years. And so we've kind of planned for a linear growth over that period of time, utilizing those growth numbers. So with the plant cost, there's a rather significant increase in terms of what your monthly bill would look like, simply because once you add the debt service associated with the new plant, you got to start paying it back. And in the early years, you're dividing that cost by the existing taps that we have currently, the existing customer base, which right now the number that we're using is 1,374. As I said, we're anticipating doubling that to almost 3,000. But the cost would increase based upon those numbers. And as Patrick mentioned, the Infrastructure and Jobs Act has a significant amount of money that would be available for principal forgiveness. So our $28 million plant is going to come down in cost. In early discussions, we've been told that we're probably in the realm of maybe having $5 million of principal forgiveness that's going to come off the cost of the project. So that brings the cost down. And chart behind me talks about in terms of what those costs would be. Right now, the rate structure in Silt allows for a base rate that allows 2,000 gallons of water use on a monthly basis. The average customer uses approximately 6,000 gallons of water a month. Under the current rate structure, that average customer is paying about $50. When we look at the cost of the plant, less what we believe we're going to be able to get from the Infrastructure and Jobs Act money, and including the ability to grow, we're looking at about a $100 increase on a monthly basis for the utility rate. So that person that was paying $50 a month would now be paying $150 a month. And these are very preliminary numbers right now. It's just raw data in terms of what the debt service would look like, divided out by the current users, which is the 1374 number that I mentioned earlier. As that number grows, that $100 impact is going to continue to drop, but we don't want to count on too much growth because, as we all know, growth is rather cyclical, and so we don't want to give a number that is going to be understating what the actual impact is going to be. So Boiling it all down, the plant as it's currently designed will have an impact of about $100 a month on the utility bills. So if you're paying $50 now, you're going to be paying about $150 in the future.